All right, everybody, we are going to do a video that discusses systems of linear equations. And we're going to talk about how you know what a solution looks like for a system of linear equations. And then we're going to talk about two different ways to solve them. So if you'll just take a look here, I've got a system of equations. We use the curly Q brackets, similar to what we would use when we did a piecewise function. So x plus 2y equals 2, that's one of my linear equations. X minus 2y equals 6, that's my other linear equation. And whenever we look at this, we say, okay, I've got two different equations. Let me see, the question says, are the following solutions of the system of linear equations? So they actually give me, in this problem, in this example, they give me 2 points. One is 4, -1, and the other is -4 and 3. And the only way to know if these are solutions to the system, so the idea is I've got an equation here, I've got an equation here, and they're going to somehow work together, or we're going to see if they cross or if they overlap or whatever. The only way for me to check is to actually plug in your points. And they have to work in both equations. Plug in your points in both equations. If they work in both equations, then indeed they are a solution. So let's try. Here's my x and here's my y, right? So in this first equation, I have x plus 2y equals 2. Let me plug in. I've got x equals 4 plus 2 times y equals -1 equals 2. So for the first equation, whenever I plug this in, I say, well, we've got 4 plus a -1 times 2 is -2 equals 2. And I want to know, is that a true statement or a false statement? And when I look at that, I go, yeah, 4 minus 2 is 2. So good. So what I know is that this point works in the first equation, but I'm not sure if it works in both until I check both. So you cannot just assume. So let's see. The second equation is x minus 2y equals 6. So when I plug it in, I get 4 minus 2 times -1 equals 6. And sure enough, -2 times -1 is a +2. So 4 plus 2 equals 6. And indeed, 4 plus 2 is 6. So this one works in both equations. So this is also true. So if your point works in both equations, then it is a solution to the system. All right, so it works in both. So what that means for me, if your point works in both equations, then it is a solution to the system. So graphically speaking, let me come back up here. I'll come back down if you need that, or you can pause and rewind. And I'm going to talk about what these two equations look like. X plus 2y equals 2. I'm just going to graph them really quickly. And I'm going to use the intercept method to do it. If x is 0, 2y equals 2, or y equals 1, right? So I've got the point 0, 1 here. And if y is 0, then x equals 2. So I've got this point here, okay? So the first line is going to look something like this. And if you need to solve it for y and figure out your slope and your intercept, you can do that. Or you could just plot 2 or 3 points and see what's going on. Okay, let me do the other line. The other line, if I put in x equals 0 to find the y-intercept, then I get y equals -3, right? Solve that. If you need to, take a second, go ahead and plot them out. So there's that point. If I put in a 0 for the y, then I get x equals 6. 1, 2, 3, 4, 5, 6. Okay, so this graph looks something like that. And if you'll look right here, 1, 2, 3, 4, -1, that's the point 4, -1. you see that that works on both equations. So indeed, that is a solution to both equations at the same time. That is the intersection of those two graphs. So when I have two lines that are intersecting in just one point like this, then the solution for it works in both, okay? So it's going to be this spot right here where they overlap. Well, because of that, by the way, because we've already found our solution, this is a solution, yay. That tells me that this point's not going to work in both equations. So let's double check and see what's going on here. So this says, take the point. So my equation was x plus 2y equals 2. Take the point -4 and 3, right? This is the one I'm working on, and plug it in. So -4 plus 2 times 3 equals 2. Well, -4, this is going to be a 6. -4 plus 6 is indeed 2. Okay, that works. Yay. All right, so maybe we're thinking, hey, we're well on the way to this second point being a solution. Now, my question is, will these are straight lines, right? Will one of them ever double back and come back and touch the other one again? In my head, I hear you saying, no, it's not going to happen. If these were quadratics, if they were curvy things like this, then we might get more than one solution for this guy. But because these are both straight lines, we're not going to do that. So we already have our solution. So that tells me when I look at this other equation, x minus 2y equals 6, I don't think this point is going to work there, but let's double check. -4 minus 2 times 3 equals 6. Well, that's -4 minus 6. Well, hang on a second. -4 minus 6 is -2, 10. Okay, so does -10 equal 6? No. So this guy is false. Okay, all the others were okay, which tells me this point -4, -3, that it actually works on that first equation that I drew, this one right here. So if you followed through, -4 would be down here, and 3 would be up here. Somewhere right in there is that point. So that point works on that equation. The problem is it doesn't work on the other one. So the solution to this system is going to work in both equations. So just make sure you're aware of that. So the solution to the system of linear equations will work in both equations. If it's for the whole entire system, it's going to work in both equations. That's what you know. All right. So that's very good. No issues. You can check points that way. You can solve things graphically like what I did here to find out what the solution is. That's not a very efficient manner of solving these things. So we're going to spend our time today focused on two methods for how in the world, so this, they told me that's a solution, or they said check it, right? But how in the world am I going to come up with one of those points to begin with? So the bulk of this video, where we're looking for the solution to two linear equations, and by the way, later we'll do 3 equations, or we'll do 3 variables, so you may have X, Y, and Z, that kind of stuff. So whenever we're looking for the solution, before we get all crazy and get big stuff going on, we want to see, how do we even find one of those points to know that it's one of the system's solutions? Okay, so here's what you got. 2 basic ways to do this. You need to eliminate one of the variables, because it's not easy for me to solve stuff that has both an X and a Y in it, right? So I'm going to get it down to where I have just one variable that I'm working with. And I don't care which variable. If you prefer to get X by itself, sometimes Y is easier. We'll just see how it works. But we're going to eliminate one of the variables, and there's 2 methods that we're going to look at today. Okay, one is substitution, and the other one is called elimination. Okay, and we're going to see a couple of examples of each, and we're going to work on it, and you will see when do I need to do which one, or what's the difference between them and all that. So I have a system here. It is, here's my example. 5x minus 4y equals 9. And x minus 2y equals -3. Okay. And so to do substitution, we're going to solve using substitution. Okay. There are a few steps. I'm going to leave myself a little bit of space over here. Number one, solve one equation for one variable. And again, it doesn't matter which one we use. It doesn't matter which equation. It doesn't matter which variable. But when I look at this second equation, I see that x is all by itself. And that's going to be the easy one to solve for, right? I can just take this second equation and I can set it up so that I can solve for x. So if there's an easier one for you to work with, then go ahead and do that. So I'm going to probably work off of this second equation. Step number 2. Use your answer from step number 1 to substitute into the other equation. I'm going to shorten that to EQN, sorry, equation, okay, just out of space. And then step number 3 is going to be solve for the variable that is left over. I need a tiny bit more space, so I'm going to add to this box, but step number 3 is solve for the variable that's left over. I'll show you all this in just a second. Step number 4 is back substitute. I'll show you what I mean by that. Back substitute to solve for the other variable. And then, like everything else, we need to probably check our answers at the very, very end to make sure, because there's a lot of steps going on here. So there's a lot of places I can mess stuff up. Okay, so we're going to do this one by substitution. So here I'm going to solve for x. This is what it's going to look like. So I'm going to take this equation, x minus 2y equals -3, and I'm going to solve for x. So get rid of this -2y. I'm going to add 2y to both sides. Boom, x equals 2y minus 3. Easy enough, right? That's why I choose the second equation, because there's only a 1 sitting out in front of that x, right? And so that's easier for me to get rid of the rest of the stuff. If I had picked this first equation, it would be fine, but like if I was solving for x, I'd add the 4y over, but then I'd have to divide by 5 to get the x all by itself, right? So that's extra work. So if I can work off that second one, I will. Okay, so solve one equation for one variable. We did that. Boom. Use your answer, this answer from number 1 to substitute into the other equation. What that means is I'm going to take this guy, it's solved for x, and I'm going to plug it into the first equation where I see the x. Okay, so in other words, I'm going to bring this stuff down. It's 5. I'm going to put parentheses where the x is, because that's what I'm going to substitute for. Minus 4y equals 9. So bring that first equation down. The other equation, not the one I just solved, the other equation. And where I see an x, instead, I'm going to write what the x equals to. So the x equals 2y minus 3. I'm going to substitute that in, okay? And what you'll notice is now I've got that very first equation, but it's only got a y in there because I substituted out the x. So it's a substitution method, okay? Now what? Now multiply that 5 through. I've got 10y minus 15. Minus 4y equals 9. This is going to be 10y minus 4y. That's 6y, right? Minus 15 equals 9. I got to get rid of that -15. I'm going to add 15 to both sides. That's going to go away. 6y equals 9 plus 15 is 24. And last but not least, solve for y, right? So step 3 was solve for the variable that's left over. That's what I'm doing here. So slow down and do it on your own if you need to, but I feel like we've been solving for y since the beginning of the semester. So most of you are pretty good at it. So I've got y equals 24 divided by 6 is a 4. Okay. So once you substitute that other equation in, solve for that second variable, whatever it is, you get an answer. I'm done with number 3, right? And now what's it say? Back substitute, solve for the other variable. Well, look here. We had this equation, right? X equals 2y minus 3. It's already solved for the x. And now I know, hey, look, y equals 4. Substitute that back in. That's what they mean by back substitute. So x equals 2 times 4 minus 3. 2 times 4 is 8 minus 3 or 5. Okay. So that tells me x equals 5, right? Put it in the correct order. X comes first. Y equals 4. That's my solution. Okay, a 5 and a 4. Now, you want to check it and make sure you go back to the original equations. So one of the equations was, don't go back to that x equals negative 2y or x equals 2y minus 3 because I might have made a mistake. Go back to the very, very beginning. 5 times x is 5 minus 4 times x is y, or I'm sorry, y is 4 equals 9. 5 times 5 is 25 minus 16 equals 9. Sure enough, it does. That's the first equation. So this point works in the first equation, but what? I have to check it in the second equation. X minus 2y equals negative 3. Well, x was 5 minus 2 times 4 equals negative 3. 5 minus 8 equals negative 3. Sure enough, look at that. So you do need to go back and check your work on these because it's very, very easy to make mistakes. And we want to make sure that in the middle of this process, when I have a solution, which I do, 5, 4, that's the solution for my system here, that it works in both equations, all right? There we go. So now we have a system solution. Cool, I like it. So I'm going to give you one, and I'd like for you to take some time and work it by yourself. So go ahead and turn off the video, pause it once you have the thing. Here's your example, and work it all on your own. And then I will come back with the actual answer and I'll walk us through it. Okay, so the solution is, oh, I'm sorry, the system is, not solution, 3x plus 2y equals 4, and 2x plus y equals 1. Okay, so again, go through the steps. They're right here. Boom. Solve one equation for one variable. Use your answer from number 1. Solve for the other variable. Back substitute. So we can, I'm going to sit them right there side by side. So go ahead and pause your video, work through it, and see if you can get there. And then when you're done, push play again. All right. So I'm assuming that you did that, and I'm going to take this second equation again. It's not always the second equation, but look here. That y is just all by itself there. So I'm going to take 2x plus y equals 1, and I'm going to solve for y. That's going to become, leave the y by itself, move the 2x by subtracting on both sides. So I've got y equals negative 2x plus 1. Okay, that's step 1. Solve one of the equations for one of the variables. Done. I've got the y all by itself. Step number 2. Okay, so if you're trying to keep up, that's step number 1. Oops, sorry, I'll put it out here. Step number 1. Step number 2 says use your answer to substitute into the other equation. Well, the other equation in this case is the first equation, right? So I've got it solved for y. So I'm going to come down here and say 3x plus 2 times the y, I'll substitute in a minute, equals 4. And I need to know, what am I substituting in? Well, this stuff that I solved in number 1. Okay. So back substitute that, or substitute that back in, negative 2x plus 1. I did that, so I've substituted in to the other equation, and step number 3 is solve for the variable that's left over. So the variable that's left over in this case is the x. So let me solve for that. 3x, I'm going to distribute this 2 minus 4x plus 2 equals 4. Negative x plus 2 equals 4. I need to subtract this 4 off. So minus 2, subtract the 2 off. So what I've got is negative x equals a positive 2, or x equals negative 2. That's what I really need. X equals negative 2. Oh, sorry. There we go. There's my answer. X equals negative 2. All right. So now I've got a solution to number 3. Number 4 is back substitute and solve for the other variable. Well, I'm going to back substitute. Here's number 4. I'm going to back substitute in right here. So y equals negative 2x plus 1. And I'm going to use this negative 2 in there, right? That's what I'm going to plug in. So instead of x, I'm going to put in negative 2. So this is going to look like y equals negative 2 times negative 2 plus 1. But a negative times a negative is a positive. So this is a positive 4 plus 1 is a 5. So y equals 5. All right, so I've got 2 answers. I've got an x and a y. So my point here should be the point negative 2, 5. So that's the answer to number 4. And then the very last step is check your work. So number 5, we're going to check it out and see. Let's get my 2 equations down here. The first equation, go back to the original. Don't come in here. Go back to the very original that was the problem that you were given. So the equation I was given was 3x plus 2y equals 4. And I'm going to use this point. That's my solution, I think. We're going to check it. So instead of x, I'm going to put in a negative 2. Instead of a y, I'm going to put in a 5. And then we're just going to check. So 3 times negative 2 is negative 6. 2 times 5 is a positive 10 equals 4. Is negative 6 plus 4 equal to, or I'm sorry, negative 6 plus 10 equal to 4? The answer is yes. So there's my first system, or my first equation, and it worked. The second equation is 2x plus y equals 1. And again, I'm going to plug in this into it. So 2 times negative 2 plus a 5 equals a 1. Well, let's check it and see. What's 2 times negative 2? Negative 4, Dr. Webster. That's what I hear in my head. Sorry, voices in my head. Negative 4 plus 5 is indeed a positive 1. So yes, that point works in both of my equations. So I am good. Check my answer. That guy works. Okay. All right. So that's how substitution works. So hopefully all of that makes sense. You're going to have some opportunities on the homework for you to work through and make sure that you're okay with it. And we are going to move on. So we did substitution. The second method is going to be elimination. So let me get you some elimination problems and we will work on those. So here you go. Example is 3x plus 2y equals 4. Oh, hang on, I'm sorry. That is exactly the equation I just did. So let me give you a different equation. I'm like, wait, that looks familiar. Skip on down in my notes. So here's my example. 3x minus 4y equals 11. And negative 3x plus 2y equals 7. Okay. This is one of the, I would say, kind of easier ways to look at the elimination method. And the reason sometimes it's called addition. Okay. Elimination method. Or sometimes you'll hear it called addition method. Okay. And the reason why this is going to be one of the easier ones is because when I look at these two equations, I see, hey, one of these guys is a positive and one of these guys is a negative, but they're the same, right? 3x and negative 3x. They just have different signs in front of them. So what we're going to do in this case is we're going to add these two equations together and put a big old plus sign in front of them and figure out what's going on. That's the idea of the elimination or the addition. And it gets a little more complicated later, so I'm going to do it this way. And this one's going to be, okay, well, if I add 3x plus negative 3x, that actually is a 0, right? So see how the x variable gets eliminated? It's just gone, okay? Then I'm going to have an equation like I did earlier, and it's only going to have one variable when I finish adding these. So I add x's and x's. I add my y's and my y's, so negative 4y plus 2y is a negative 2y. And then I add my constants, so equals 11 plus 7, that's an 18, right? Okay. So now I say, oh, I'm solving for y. So it ends up being very similar to what we did just a second ago. Divide by negative 2, y equals negative 9, right? Okay, so I've got a y value there. And then the way it works is I just need to substitute that back in. And you can pick either equation you want to substitute into. I'm going to pick this positive guy here where the x was a positive term. 3x minus 4 times the y is a negative 9 to substitute into. That equals 11. That way, at least my x is positive. So I've got 3x, negative 4 times negative 9 is a positive 36 equals 11. Subtract the 36 over. Okay. 3x equals, let me scoot. Okay, is that negative 25? I'm looking, I don't even have the actual solution in front of me. I'm sorry. So negative 25, yep. And then whenever I get finished with that, I'll say, oh, I got to solve for x, divide by 3, divide by 3. It's not going to simplify. So unless I did this math wrong, 36, subtract 36 minus 11 is 25. It's negative. So I think I'm right on the math. So just check me and see, but I'm pretty sure it's right. 36. Just trying to, I don't want to lie. I'm surprised it's not a nice round number, but yeah. So I'm just going to leave it as negative 25 over 3. And so I have a solution, right? The x value is this negative 25 over 3. And my y value is negative 9. Okay. So that's kind of the idea of it. I'm going to scoot back and we're going to get our steps because I didn't give them to you yet. The reason I didn't give them to you yet is because this one, like I said, it's one of the easier cases. They already had it set up for me so that I could get rid of these x's very easily, right? They already had it multiplied out properly for me. So that makes my life nice. But there are steps to get there. So step number 1, write both equations in, and they call it ax plus by equals c form. Okay, what that means for us is the x's are together, the y's are together, and then the constants, c for constant, are off here by themselves. They had already done that for me, so that was nice of them, but they're not always going to be like that. But you want them to be in the same format so that you can easily get rid of one of the variables, right? If it was like this x plus y, and then the other one was y equals 3x minus 7, then they're not on the same spot. I need to rearrange them, okay? Number 2, if needed, multiply one or both equations by a number that will allow you to eliminate one of the variables. And again, we don't care which one of the variables. We just need to eliminate one of the variables. Okay, this is the step that's going to take some thought. Okay, it didn't take any thought here because they had it set up for me, right? They had the 3x and the negative 3x. But if you'll notice, there's two things that I needed to have happen there. They needed to be the same coefficient, and one needs to be a positive and one needs to be a negative. If that's the case, then when I add them, this will automatically go away, right? So same coefficient. So let me put, I'm going to add that in there. Make one variables have the same coefficient, except one is positive and one negative. And that's what I mean by multiply by whatever's necessary, so that when you add these equations, one of the variables is going to go away. All right, step number 3. Add the two equations. If we've done step number 1 and step number 2 correctly, one of the variables will be eliminated. Will be eliminated. That's what we're after. Okay, if I've done it right. Okay, add those two equations together. Step number 4, solve the equation for one variable. Solve for the variable that's left over. There will only be one variable, right? Because I eliminated one of them. Solve for the variable. And step number 5, exactly what we did earlier. We're going to back substitute. So from here on out, from 4, 5, and 6, it's all the same as what we did for substitution. Back substitution to solve for the other variable. Okay, we did that a minute ago. That sounds right. And then the last step is number 6. We need to check our answers, right? Always need to check. Okay. So numbers 1, 2, and 3 are the ones that we have to do specifically because we're doing the elimination or the addition method. 4, 5, and 6 are universal no matter which method I'm using here. So they look the same. All right, so let's get one that's a little more complicated than the one that was already preset up for me, right? That was nice of them to preset it up, but it's not exactly the way it usually works. So let's see what we got. Okay, and then we'll do one that's more complicated and that will help us all out. All right, this system of equations is 3x plus 2y equals 48 and 9x minus 8y equals negative 24. Okay. So they're already in x plus y equals c format, so that's good. But as I'm looking at it, I say one of these is probably just slightly easier to get rid of. Okay. If I was looking at the x's, there's a 3x and a 9x. Yes, I could multiply that top guy by negative 3 to get a negative 9 so that those would eliminate. But look right here. Look at those y's. A 2y and a negative 8y. Look, one of them already has a positive and one of them already has a negative. So I think this one's just going to be slightly easier for me to get rid of, because all I got to do is multiply this first equation by a 4. Because 4 times 2y is going to be 8y, and then those two are going to go away, which will be nice, okay? But just remember, if you're multiplying the first equation by 4, you have to multiply every single term by the 4. So you're going to have to be a little bit careful in here. But I think that's going to be the easier one to eliminate. So here we go. 4 times 3x is 12x plus 4 times 2y is 8y is equal to, and this I've got to be a little bit careful, do my math, sorry. 48 times 4 is, come on, 48 times 4, 192, okay, and then the other equation, I didn't do anything to it, right? 9x minus 8y equals negative 24. Sometimes you'll have to, like, if this was, I don't know, a 3 instead of an 8, I might have to multiply the second equation by something as well to get rid of the y's here or the x's. You can go by either one. But because it was an 8, I didn't have to do anything because now these line up, right? I've got a positive 8y and a negative 8y. And when I do step 3, which is add, so this was step 2. Step 1 was already done for me. This is step 3. Okay, 12x plus 9x is 21x. 8y plus negative 8y, that's exactly what I want it to look like. That's going to be a 0, is equal to 192 minus 24 is 168. And now I've got 21x equals 168, and I'm hoping that divides evenly. Sure enough, x equals 8. All right, yay. All right, and that's the biggest bulk of the problem. Now I need to back substitute. I solved for the variable that was right here. That's step 4, right? Now I'm going to back substitute. So let's go back in here. I have x equals 8. It doesn't matter which equation I use. So I'm going to say 3 times 8 plus 2 times y equals 48. And 3 times 8 is 24 plus 2y equals 48. And then I'm just going to subtract the 24 from both sides. That's going to give me 2y equals 24. And lo and behold, when I divide by 2 on both sides, I get y equals 12. So I have an x value and a y value. My point is 8 and 12. That's what I think is the solution here. I totally just cheated a little bit and checked my answer. That's what the book says too. So I'm going to leave it to you guys to do step number 6. So this was step number 5. Step number 6 is check. And make sure that that answer does indeed work in both of my equations. 8 for the x, 12 for the y. But I checked in the book and it does. So I'm going to cheat a little bit and skip it. All right. So let's see one that's just a tad bit harder. And then I'll let you go work on your homework so that you can see some stuff. So this example says, we're still going to do elimination or addition. Solve a system by the addition method. And it says 2x is equal to 7y minus 17. And 5y is equal to 17 minus 3x. All right, well, here were my steps. Number 1, write both of the equations in ax plus by equals c format. Well, it is not in that format. So I need to start with step number 1 on this one. I'm going to move things around. So I need the x, 2x. I need the y on this side, which means I'm going to have to subtract 7y. So minus 7y equals the negative 17. So that's x plus y equals constant. I'm good. This guy's got the y over here. So I'm going to rearrange this. I need to move the x over, right? So the plus 5y is okay, equals 17. But I need to get rid of this negative 3x. I'm going to do that by adding 3x to both sides. So this is going to be 3x plus 5y equals 17. All right. If needed, multiply one or both equations by a number that will allow you to eliminate one of the variables. Okay, I can do that. So when I look at this, I go, hey, these are positives, but this guy here, one's a positive, one's a negative. Again, you can get rid of whichever variable you want to, but when I look here and I see there's a ready-made positive and negative in there, I'm probably going to use that one. The problem is what? This guy is 7y and this guy is 5y. And those don't have anything in common. Like the one that I did earlier was a 2 and an 8, so it was easier for me because I only had to multiply 1. Since these don't have anything in common, it's gonna kind of be like finding a common denominator. I need to know a number both of these will go into. And so I say 7 times 5 is 35. So I'm going to multiply the top equation by 5 and the bottom equation by 7. Okay, and we'll see how that looks for me. So this is step number 2. Oops, step number 2. All right, multiply that 5 through everything. So 5 times 2x is 10x. 5 times negative 7y, negative 35y. And 5 times 17, oh my gosh, I don't even know what that math is. 5 times 17 is 85, and it's negative, right? Because the 17 was negative. So that equals negative 85. Okay. 7 times the second equation, and I highly recommend you stop and multiply it yourself and make sure you can get there, because this is math you're going to have to do on your own. So if you're not sure, 7 times 3x is 21x. 7 times 5y is a positive 35y is equal to 17 times 7, 119. Okay. Okay, and now if I am at this spot and I see, look here, those y's have the same coefficient, one's a positive, one's a negative, then I know I can do the addition method. I can add these two equations, and when I'm done, negative 35y and positive 35y is going to be 0y. That's going to get eliminated, and that's what I'm after, right? Okay, so add the two equations. This is step number 3. All right, 10x and 21x is 31x plus 0y is equal to, when I add these together, I get a 34. 119 minus 85 is 34. All right, and then what? I'm sorry, hang on a second. Yeah, I'm good. Okay, sorry. I had a little bit of a moment there where I was like, what am I doing? But I'm good. All right, so I look at it and I say 31, it's just a weird answer is the problem. 31x equals 34. I'm going to divide both sides by 31. And so my x is going to be 34 over 31. It's just a weird answer. I was making sure I didn't make an arithmetic mistake, because sometimes when you do that and you get something really close, you're thinking, well, it should be 34 over 34 or 31 over 31 so that it'll reduce. But this one is not, FYI. Okay. So we got our solution. So add the two equations. One of the variables will be eliminated. Solve for the variable. That's step number 4 right here. Just solved for that variable. And step number 5 says back substitution to solve for the other variable. So let's come back up here. Sorry, I need a new piece of paper. Come back up here, find your original equations. It does not matter which one we're doing, but this is negative 34 over 31. I don't think it's going to be very pretty. So it doesn't really matter which one. And that was my X value. I'm just going to stick it into this first guy. You could put it in whichever one you want to, but I'm going to back substitute into the first equation, 34 over 31. There's not a reason that I picked that. I was looking to see if one of them would be nicer than the other to eliminate something, to reduce, and it just isn't. It's just kind of ugly. So I'm going to go 2 over 1 here, and I'm going to multiply straight across the top. 2 times 34 is 68 over 1 times 31 is 31. 7y minus 17. So I'm going to try to get the y guy completely by himself. So I need to add this 17 to both sides. This is going to get ugly. I'm sorry. It's going to equal 7y, but I've got 68 over 31 plus, and I'm adding 17, but that's 17 over 1. And I really need a common denominator. And between 1 and 31, the common denominator, unfortunately, is 31. So I'm going to multiply here by 31 and here by 31. Got to get a common denominator because I can't add these fractions without a common denominator. That stinks. So 17 with a 31 on the bottom is 527. Oh, that's a big number. And when I add these, that equals 7y. When I add these, I've got 595 over 31 equals 7y. It's just not pretty, I'm sorry. And I'm going to try to divide those, and it doesn't go evenly. So I've just got this ugly answer here. All right. So I need the y by itself, divide by 7, or you can think multiply by 1 over 7, right? Or you can invert and multiply, whatever you want. So y equals, let me see if please 595 divide by 7. And it does. When I do 595 divided by 7, I get 85. Yay. So this will reduce. That's nice. 85 on top and 31 on bottom. And when I look at those, 31's a prime number. So this is not going to, and it doesn't go into the 85 evenly. So it's not going to reduce any and be pretty or anything like that. So I do have a solution. That's the nice part. It's just not a pretty solution, but it is a solution. 34 over 31 for the x value. And 85 over 31 for the y value. That is my answer. And as I look in the book, that is the answer. So you can check it and make sure. All of this, by the way, was step number 5. So all of that. Step number 6 is check it. And I just am going to leave that for you to work on. All right. So that last one was kind of icky, but we got through it. It's just fractions. You can work with them. Those are the 2 methods, substitution and elimination, or adding. And then I'll have a follow-up video about this next week. All right, so that we can check our skills and see how we're doing. Hope that helps, and I will talk to you soon. Let me know if you have questions.